given such problems where we do not know how to write a program for a particular problem, we have the ability to apply statistics on that particular set of problems. So in a scenario where we do not know what to do, so for example, let's say that we sent a robot on Mars. Weird thing, we will never do that, but let's say that we sent a particular robot to Mars, and we have no idea as to how that particular robot should behave in a completely unknown environment. In that scenario, what can we do is something that we can apply with respect to data, that we get data from that system, and then we say that, okay, given this particular set of data, we should need to do something like this. So for example, let's say that we want to navigate our way through some territory along some Martian environment. In that scenario, we know that our robot is able to move forward, our robot is able to move along in some particular areas that we can allow, but our robot cannot move along obstacles. In such scenarios, what we can do is get an image from that particular environment and then apply that data to figure out a way in order to navigate our way through this particular environment. So essentially, when the reason for using machine learning is cases where human expertise does not exist, for example, navigating on Mars, or in other cases where human expertise does exist, but we do not have a way of explaining that particular expertise. So for example, let's say that we do not, so we can understand speech, but we do not know how to explain that individual words, how to explain individual paragraphs or essays, and how what do they mean in terms of what they can explain. So let's say that I can tell you the meaning of individual words, but what those words mean in terms of their entire existence in their essay, in an essay or a paragraph, is different, because we can combine multiple words together, and then we can basically create an essay or create a paragraph that can mean different things. So we can't explain how those words combined together can mean different things. Finally, we can also think about systems where a program, so when I say a program, think about a computer program. When I talked about sorting algorithms, or we talked about finding if a number is prime or not, but those were specific cases. But let's say that we had programs that are designed to be customized by you. So let's say that you would like to see particular articles that are relevant to you. In such scenarios, we call these programs as personalized programs, right? So in these programs, essentially, you would basically be saying that I would like to have a particular program that is designed particularly for me, and it would show me articles that are relevant to me, that are also applicable in case of personalized medicine stuff, where I would want my particular program to work in terms of my needs and my medical benefits, right? So I would want my algorithm to figure out if a particular medicine is right for me, if I need to take that particular medicine now, or if I need to take a particular medicine a day after today. So I would like my program to be customized to me. In such scenarios, it is often difficult for me to write a program for you that can figure out whether the particular medicine is an important artifact in order for me to figure out that I should take this medicine or not, or for example, I should get this article or not. So that is essentially user personalized medicine or user personalized data. So in such scenarios, we would like our program to be able to figure out some things with respect to data. It would get data from me, it would get data from the general users as well, and then it would basically figure out an algorithm that can tell me that, okay, this particular medicine is for me, or for example, in case of speech recognition, it would say that this particular entire book can be summarized to this particular paragraph, right? So whenever we have a large amount of data, we apply machine learning algorithms to figure out certain statistics about that particular algorithm, and then we are able to output some very interesting things about this particular set of data points. So let's before we begin as to what machine learning is and how they work, let's just talk about a few examples as to how machine learning has helped a lot of sciences in the computational field. So I guess everyone here has heard about a few great things that machine learning algorithms are able to tackle. That is self-driving cars, right? So I'm sure that everyone here has heard of self-driving cars. Let me just ask. Okay, so see a couple of cases. So yes, so self-driving cars essentially mean that you would just set your navigation point to a particular location, get in your car, go to sleep, and when you wake up, you would basically find yourself in that particular location. So in that entire period, the car is essentially going to go through entire traffic and obstacles and entire traffic and obstacles essentially, and then take you to that particular location. But if you think about it, what it needs to do is essentially figure out a way to get to that particular location using some sort of a map. And then it also needs to do many more things. It needs to figure out if a car is ahead of you so that it can stop, if there is an obstacle ahead of you so that it can stop in case it needs to stop. And then it also needs to figure out if it is in the correct lane. So in that scenario, it would need to figure out if given a particular roadway or given a particular 2 lanes or 3 lanes or any sort of system, it would need to figure out that it needs to stay at the right lane, lane being defined as the way we need to go, and also if there are cars there. And then given that image, it needs to figure out if it should go that particular location. A fun thing about self-driving cars is it is a much more difficult problem, but people have designed programs or machine learning algorithms that basically apply this particular algorithm to race cars as well. So in case of self-driving race cars, essentially people have basically designed a set of algorithms that can be applied to cars, or in that particular scenario, F1 cars in that scenario. And then you can actually have computerized cars that can actually complete a lap without ever crashing into another car or without ever crashing into an obstacle, right? So essentially in such scenarios, you would need your program to be able to complete a few things. First, detect obstacles, detect lanes in your roads, and second, and thirdly, basically be able to manipulate or control that particular car in real time or in linear time, such that given a particular image, I am able to figure out whether I should turn left, I should turn right, how much I should turn, and then I also need to figure out if I need to avoid any obstacles or not. Another example for machine learning algorithms that is really popular is the list of MNIST dataset, right? So MNIST is example dataset that takes in images of human written digits and tries to figure out if a particular digit is represented. So for example, humans write numbers very weirdly. So let's say that I want to write a particular program that can detect if a particular written image or a particular written digit is 0 or all the way to 9, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So imagine writing a program that is not for machine learning, but can detect particular images, and then particularly if that particular image has a digit in it. But since humans write all sort of weird digits, let's say that I can write the number 2 in either way, right? So I can write number 2's normal, in case of different people, I can write the number 2 in different ways, right? So I cannot actually write a program that can detect the number 2. So what I can do is ask my computer to detect whether this particular digit is a number, and if it's a number, what number is this? So I do not know how all humans write numbers, but I can give my computer a lot of different examples as to how humans usually write the number 2. And I can then say that all set of these numbers are the number 2, right? So then your computer can basically detect whether this has a sort of pattern in it or not, and then figure out if that particular number is 2 or not. So this particular application of computer programs was researched quite a lot, and then people basically figured out that there is no deterministic program as to how humans write digits, right? So for example, a human can write the number 3 like this, but if you write a program in order to detect if it's a number 3 or not, or if it's a number, if it's a digit or not, most likely that you would identify this particular digit as the number 2. So there are errors as to how humans write different programs, but if we give a lot of data to your computer and ask it to figure out whether this is a particular number or not, in that scenario, your computer would be able to find patterns in that particular representation, and then figure out if we have a particular digit. If we have a digit, then what digit is this, right? So this was applied to, for example, whenever you submit a check to your banking ATM, right? So if it's a handwritten check, in that scenario, your computer has to figure out if that has numbers, and if it has numbers, what is the amount that you are trying to transfer. So you usually would have given this to a bank teller or a human person, and a human person would be able to figure out whether that has a number or what is the amount that you're trying to transfer. But if you want to automate this process, you would need to detect that you are trying to transfer a particular amount, what that amount is.